All right, let's talk about the address resolution protocol. So again, we're still at the data link layer. The address resolution protocol is still handling communications directly between devices, meaning it's helping you get messages from you to your router so that your router can get the message outside of your network. So, bit of a review here. To send something to Amazon, if I wanted to send data to Amazon, I would take the HTTP request, pack it inside of a TCP segment, pack that TCP segment inside of an IP packet. And the IP packet is going to have a destination IP address, in this case, Amazon's IP address, 54.239.17.6. Amazon's got a bunch of IP addresses, that's one of them. That's going to be the destination IP address of that packet. Now that packet then is designed to get all the way from you to the destination, Amazon, without needing to be unpacked and changed in any way. But unfortunately, we can't just transmit a message automatically, magically, in a twinkle to Amazon. We have to do some work to get it there, and we have to go through a whole bunch of steps along the way. So we take that IP packet with the destination IP address, and we pack that into a frame. Now, what do we put as the destination MAC address? That is where ARP comes in, because we can't put Amazon's MAC address because we can't talk directly to Amazon, and the data link layer happens with direct communication between devices. So the data link layer, remember, physical communication between physically connected devices. We can't send it all the way to Amazon. So how do we get it there? We get it there through routing, and specifically, one little bit at a time. Each step along the path determines the next hop. So when we talked about routing, we've got the default gateway. And for your device, basically anything that's not for your internal network is going to the default gateway. For your router, if it's at your home, basically anything that's not for your internal network goes to Cox and goes to their default gateway, or your router's default gateway. And those are all next hops, meaning we're looking at what's the next step along the path. What's the next router or device I have to go through to get ultimately to my final destination in a while. And ARP figures out how to do that. So routing handles figuring out the IP address of the next device. ARP figures out how to get it there at the data link layer, which next layer down is how we handle that direct device-to-device communication. And ARP stands for the Address Resolution Protocol. Remember, the network layer uses IP addresses. The data link layer uses MAC addresses. ARP connects those two. And what it does, it's a method for getting the MAC address of the next hop device. So we have the IP address from routing, the routing table and all that stuff, and default gateway, all that figures out what the IP address is of the next device. We need the MAC address to be able to transmit anything, and ARP will get us that next hop. Now, if we were sending something directly within our network, the next hop would be the device that I want to talk to. ARP would get us the MAC address of the device I want to talk to inside my local network as well. And the way it does this is through the first step, an ARP request. And this is a broadcast message to a broadcast MAC address, which is FFFFFFFFFFFFFF. I hope that's enough Fs. Broadcast out to everybody on your local network. So everybody inside of your network hears this ARP request. And the message is essentially who has a certain IP address. So if it's the default gateway, who has the default gateway IP address? And please respond and tell my IP address. So I need the MAC address associated with whatever IP address it is. So if it's the default gateway, then it's that. If it's a device I'm talking to directly, then it's that. And those are going to be broadcast out to everybody on the network because we don't know the MAC address of the device that we're trying to talk to. So the only way for us to get anything to that device is through this broadcast that they'd be listening to. And in response, we get an ARP response. And this is a unicast. So we broadcast out and shout to everybody, hey, I need the MAC address of 192.168.1.1. And then that device, 192.168.1.1, is going to respond, and it's going to say 192.168 is at whatever the MAC address is of that device. So while we broadcast it out to the world, we don't expect everyone in the world, or not to the world, to our local network. We broadcast it out to our local network. We don't expect everyone on the local network to respond. We expect the device that we're asking about to respond. And when it responds, it's going to say, hi, my IP address is at my MAC address. And now we have the MAC address, right? So request goes out, we get a response, and now we know the MAC address, and now we can create the Ethernet frame or whatever frame using that MAC address. And now that we have that MAC address, we can put that frame together. So we store those in what's called the ARP Cache. And the reason we store them is so that we don't have to send out an ARP request for every frame. Because if we didn't store it, we'd have to send out an ARP request, get an ARP response for every single frame we want to send. And that would trash your network. So we have a cache. And looked up some numbers. It looks like on Linux, the default is around 60 seconds. And devices in the ARP cache are stored, or entries in the ARP cache are stored for about 60 seconds on Linux. On Windows, it's about 10 minutes. And if it's used, at least on Linux, if you use a record in the ARP cache, then it refreshes that 60 seconds. So if you're constantly communicating with a device, then that ARP cache entry is not going to expire. But if you talk to them once and then stop talking to them, then that ARP cache entry expires, and next time you want to talk to them, you have to go through ARP again. ARP-A is a command you can enter on your Windows command line to access and view what's going on in your ARP cache. It's pretty handy. It's kind of cool. There's other commands that you can use to clear your ARP cache. You can check it out in Wireshark. If you open up Wireshark and listen for long enough on your network, you're probably going to see some ARP traffic. Inside a corporate network, it'd take you probably about 5 seconds to get some ARP traffic. Inside your home, it might take a little bit longer. And that's ARP. That's our address resolution protocol.